Hello friends, welcome to the Engineering Projects YouTube channel. We have started the series of electronic devices and circuit theory by Robert L. Balested. We have discussed two chapters in our previous lectures, and these chapters are about the semiconductor diodes and semiconductor diodes applications. Now, today we will discuss about chapter number 3 and its name is bipolar junction transistor. Today our topic is transistor, and then we will discuss about bipolar junction transistor. What is transistor? Transistor means transfer resistor. Transistor is made up of two words. Number one is trans. Number two is istor. Trans means signal transfer property of device, and istor means solid element just like resistor. So in short, transistor means transferred resistor. Its introduction is how the transistors are invented and what is the history behind transistor. So we will discuss the history behind transistor in the introduction. In 1904, vacuum tubes were used, and vacuum tubes were made up of anode plus cathode, and there was a potential difference V between the anode and cathode. In 1906, a filament is added to the vacuum tube to heat cathode. To heat the cathode part of the vacuum tube, a filament is added. And what the filament do? The filament heat the cathode, and the electrons direct electrons to the anode. When the electrode is heated, the electrons will move from cathode to anode. And with the advent of TV and with the development of technologies, with the passage of time, in 1947, John Biden invented the first transistor. So the inventor of the transistor is John Biden. It is another definition of transistor. This transistor is a semiconductor device used as switch and amplifier. So it is a device which is used as switch and amplifier. How it is used as switch and amplifier, as this chapter is about bipolar junction transistor, so in our next lectures we will discuss about how the transistor is used as a switch and how it is used as an amplifier. The transistor has basically two types. Its types are the bipolar junction transistor and number two is field effect transistor. The bipolar junction transistor, the word bipolar means it will have two kinds of charges, electrons and holes. Junction mean the word junction in the bipolar junction transistor predicts that there will be two diodes connected back to back, so it has two junctions. We will have two diodes. What is diode? We have p-type material, n-type material. We connect the p-type and n-type material, and there will be a junction between the p-type and n-type material. Then this device will be called diode. When we connect two diodes, p-type material, n-type material, n-type material and p-type material back to back, then in that case it will have two junctions, two diodes, so it will have two junctions. Transistor here predicts that transfer of resistor, as we have discussed here, transferred resistor. So transistor means transfer of resistor. The junction J1, there will be two junctions. First junction will be called J1 and second junction will be called J2. The junction J1 will be forward biased, and as it is forward biased, so there will be low resistance. What is forward biased? When we have a diode, here is p-type, here is n-type. When p-type is connected to the positive terminal of battery, then we will call it as forward biased. And when p-type is connected to the negative terminal of battery, and N type is connected to the positive terminal of battery, then we will call it as reverse biased. So when the junction J1 is forward biased, in case of forward biased, our diode will have low resistance, because when diode is forward biased in this condition, then the current can flow in this direction. So as the current can flow, so it will have low resistance. J2 will be reverse biased, so it will have high resistance. Reverse biasing means no current can flow, very small amount of current can flow, which will be in micro or nanoampere. Input is applied at J1 and output is taken as at J2. So as the J1 has the low resistance and J2 has the high resistance, so signal will be transferred from low resistance to high resistance, and it will be act as amplifier. Now second type is field effect transistor, and it is a unipolar. The BJT is bipolar, but FET is unipolar. Regions of BJT. BJT has 3 terminals and its regions are base, emitter and collector. Our base is, as shown here, our base is thin and lightly doped. It is lightly doped. Our emitter is intermediate plus heavily doped. This is our emitter. It is intermediate section and it is heavily doped. Our collector is large plus intermediate doped. Our collector is large in region and it is intermediately doped. Types of BJT. We have 2 types of BJT. Number 1 is NPN transistor and number 2 is PNP transistor. NPN transistor means our collector will be N type, our base will be P type. This is our base. Base will be P type and emitter will again N type. PNP transistor means there will be a base of N type between the collector and emitter. The symbol of NPN transistor and the PNP transistor are shown here. For NPN transistor, we have a base and the line which is called collector line, and another line which will be called as emitter line. And for NPN transistor, we have the arrowhead direction outward. We have the direction of arrowhead as outward direction, as here is N, collector is N type, base is P type and emitter is again N type, and the current flow from P to N direction. You can see here current flow from P to N direction. So we will draw the direction of current. This arrow shows the direction of current. So we will draw the direction of current from P to N. Our collector is P type, base is N type, emitter is P type. So P to N. Our current direction will be from P to N for forward biasing case. Now we will discuss about the function of collector, function of base and function of emitter. Function of emitter. The function of emitter is to supply the majority charge carriers. As the emitter is heavily doped, it has more number of electrons or more number of holes, so it will supply the majority charge carriers. The majority charge carriers in case of NPN transistor, this is the case of NPN transistor. The majority charge carriers in case of NPN transistor are electrons, and the majority charge carriers in case of PNP transistors are holes. Now, emitter is always forward biased with respect to base. This is our emitter, this is our base, and this is our collector. Here are the 2 diodes. This dotted line shows that this is diode 1 and this is diode 2. Here are the 2 diodes. and emitter is forward biased with respect to base. So this is our emitter. To make it forward biased, this is our collector, and to make emitter forward biased, this is n-type material. So we have negative biasing here. Okay, so we can make our emitter forward biased. To make our emitter forward biased, we have to connect our n-type emitter with the negative terminal of battery, and base will be connected to the positive terminal of battery. So emitter will always be forward biased with respect to base. P-type emitter supply holes and n-type emitter supply electrons. This is NPN. This is our NPN transistor, and this is n-type emitter. So n-type emitter will supply electrons, as in n-type emitter electrons are the majority charge carrier. So n-type emitter will supply electrons, and p-type emitter, in case of p-type emitter, holes are the majority charge carriers. So p-type emitter will supply the holes. Function of collector. This is our collector. Collector is used to collect the majority charge carriers. The supplied majority charge carriers will be collected by the collector. Its name shows it will collect the majority charge carriers. Collector is always reverse biased with respect to base. To make our collector reverse biased, we have to connect the positive terminal of our battery with collector, so, and negative terminal of our battery with base. P-type collector receives holes, and n-type collector receives electrons from base. This is our base, and n-type collector will collect electrons, and p-type collector will collect holes. Function of base. It allows to pass the emitter injected charge carrier toward collector. So base is used to, these are the charge carriers, so its function is to allow to pass these charge carriers from emitter towards collector. Depletion layer. As we have two diodes, so we will have two depletion layer. This is our diode 1 and this is our diode 2, and this is our emitter, this is our base, and this is our collector. Emitter is highly doped, base is lightly doped, collector is intermediate doped. Now electrons, before applying the biasing, when there is no biasing condition, no battery is applied, in this case electrons will move from emitter, n-type emitter, to the p-type base, and there will be electron will move in this direction, and there will be positive potential and there will be negative potential. As it is losing electrons, so there will be positive, and base is receiving electrons, so there will be negative. A junction will be created, and this will be called junction number 1, and this will be, there will be electron also move from this n-type collector towards this p-type base, and there will be again positive and there will be negative. Now what will happen when we apply the biasing? We have applied the forward biasing to emitter and reverse biasing to collector. Then when forward biasing is applied, if you have not watched our semiconductor videos, then kindly watch our semiconductor videos. The link is provided in the description. And in this case, when our n-type is forward biased, when our diode is forward biased, then in this case the width of depletion layer decreases. Let's suppose the width of depletion layer will decreases. This, let's suppose our depletion layer this is our depletion layer. After applying the biasing, the width of depletion layer will be decreased and it will decrease to this level. For reverse biasing, the width of depletion layer will increase. Let's suppose the width of depletion layer before biasing is this, and after biasing the width of depletion layer will be increased. Okay, so this will be happen. So this is all of our lecture. If you like our lecture, then kindly subscribe our channel. Thank you.